Good morning, ladies and gentlemen. Myself, Faizan Zahid, and I'm a master's student in the field of automation engineering and control of complex system at the Department of Electrical, Electronics and Computer Engineering, University of Catania, Italy. Today, I'm going to present my recent research studies, which is based on recent constraints and challenges in battery management systems of EVs, electric vehicles. A brief review. So let's start. First of all, we will look on contents that we are going to cover today. We will go through the introduction at first, and then we will discuss research motivation about this behind this research work, and then we will see the problem statement actually, and then we will go through the literature review. After that, we will do some technical analysis, and finally we will conclude our project and will suggest some future recommendations. So first of all, introduction. As we know that electric vehicles lead the charge towards a more sustainable future, and the BMS, basically the battery management system, play a crucial role in this transition. Actually, uh, it's obviously that BMS are essential for ensuring the safety, efficiency, and longevity of EV batteries by managing crucial aspects like charge levels, temperature, and overall health. Like they act as the brain of the battery, we can say, which are very essential in organizing its operation to maximize performance and reliability. Well, basically, this presentation is going to explore the critical challenges confronting BMS, such as security, battery data from cyber threats, maintaining optimal thermal conditions, and achieving precise state estimation. And of course, addressing these challenges is key to unlocking the full potential of EV batteries. And for sure, we will delve into innovative solutions and recent research advancements, and with the aim to enhance battery performance and pave the way for a new era of efficient and reliable electric vehicles. Uh, Let us discuss something about research motivation behind this study, which is being conducted. Uh, we know that the shift to electric vehicles depends heavily on the effectiveness of battery management systems, and these systems are crucial for making sure batteries work well and last longer. There are ongoing challenges still we face, like with several aspects related to BMS of EVs. What are those issues actually we are going to explore in this presentation, and we will also find this possible solutions in future that we could recommend to the future researchers as well. So basically, our research is driven by the need to solve these problems with the aim to find practical solutions that can improve battery management system technology, and of course making batteries more efficient and reliable. To address these key issues, we are hopeful to support the growth of electric vehicles and contribute to a cleaner and more sustainable future. Um, we will see that the what is the problem statement in this study. Basically, an effective battery management system is very essential for advancing electric vehicles. So in spite of it, we can see that the key issue emergence of key issues is very important, and to detect and to get rid of, such as we have still several issues that we can experience, like data security, temperature control, and accurate state estimation, which can continue to challenge BMS technology. And there are many other issues as well that we will discuss in incoming slides. So basically, resolving these issues is essential for the sake of optimization of battery performance and ensuring the safety and reliability of electric cars. Uh, when we talk about literature review, that what the recent studies suggest about this issue and this topic. basically. So recent literature underscores critical challenges facing BMS. We are going to explore data security, thermal management, and state estimation accuracy. And of course, that can impact that have very huge impact on battery performance, its longevity, and overall vehicle efficiency. So there is some data which represents recent challenges and limitations in BMS for EVs, from the recent studies, actually, especially from the past 5 years. There are some aspects, their description and limitations, which are discussed in some recent researches. So what are those aspects actually, and what are the limitations we can face in that? Our data security, we can say that, which is important, like protecting battery data from cyber threats and BMS of electric vehicles. But there are some limitations and issues we face, of course. That is vulnerability to unauthorized access and data tampering. uh, we can face another challenge, which is very important: temperature control, that is regulating battery temperature and BMS to prevent overheating and maintain performance. But also we have a huge limitation in that, which is in efficient cooling, that leads to thermal runaway and performance loss. And we can also see a very important aspect, that is state estimation. And that is to achieve precision real-time measurements of battery state in BMS. The problem we can have in this is, we can experience inaccurate state of charge and the state of health, SOC and SOH estimates, due to complex battery behavior. And also the charging efficiency, and that can experience sometimes slow charging times and inefficiencies in existing charging infrastructure as well. And when we talk about longevity estimates, that's basically predicting battery lifespan accurately using BMS. There is some limitations, like limited accuracy in predicting battery life, that can be caused by degradation factors. There are several degradation factors that can lead to limited accuracy in predicting battery life. And of course, power stability, that plays a very important role in BMS. The important is to ensure stable and reliable power output through BMS. But there are also problems and drawbacks, which we can experience time to time. For example, fluctuations in power delivery affecting vehicle performance, and of course, cost efficiency, high production and management costs impacting the overall vehicle affordability, and battery integration. These are the basically challenges in integrating batteries and with various vehicles. So we can have a lot of an experience of difficulties in achieving seamless integration with existing vehicle architectures, and so on. If we go ahead, we can experience various other challenges like performance degradation, longevity estimates, and sustainability and disposal also is a big issue. uh, it's a kind of a big challenge. So uh, this was basically and a data which was acquired from recent studies. And based on this, we have some comprehensive technical analysis, that as electric vehicles continue to advance and advancing day by day, and of course we're similar to this, addressing these challenges, specifically with BMS, is essential to for the enhancement of their safety, reliability, sustainability, and of course their performance. So basically we are going to demonstrate some technical analysis that can highlight these key issues faced by BMS technology and their impacts on electric vehicles, operation, and different areas that require focused attention to ensure optimal functionality and reliability. So, what are these? Basically, what are the key impacts of these challenges? Like if we talk about data security vulnerabilities, there's a risk of cyber attacks on battery data, and it can impact like threats to data accuracy, unauthorized access to sensitive information, and potential system failures. um, Temperature management challenges. What type of temperature, what are the temperature management challenges, and what is the impact of those challenges? Basically, uh, poor cooling and temperature control is basically what we call the temperature management challenges that can impact overheating risks, reduced battery performance, and shorter battery life due to ineffective thermal management. And there's an other important challenge that's very common, and in last past researches, that is state estimation accuracy. It's very important, and which means inaccurate real-time battery readings, and that can impact the difficulty in tracking battery health and charge levels, and it can lead to inefficient battery use and possible performance problems. And we have also charging efficiency limitations, which can cause slow charging and inefficient infrastructure, and it can impact longer charging times, reduced convenience for users, and potential negative effects on battery lifespan. And after that, of course, longevity prediction gaps, that is unreliable battery life prediction models that can impact like uncertainty about battery lifespan, unexpected failures, and higher maintenance costs due to inaccurate lifespan estimates. And then power stability concerns. We can also have this challenge as well, that is inconsistent power delivery. Basically, it represents. It also impact variable vehicle performance, potential power supply issues, and reduce reliability of the electric vehicle. And in the end, we can see that there is a sustainability and disposable issues, which are basically environmental impact of battery disposal, and it can impact increased pollution, challenges in recycling, and greater ecological footprint, from inadequate disposal practices. To conclude, finally, this research as is comprehensive analysis from the recent studies, and this research basically provides a thorough analysis of recent studies and identifying key challenges in battery management system, especially for EVs. And these critical issues like data security, temperature management, charging efficiency directly affect EV performance and safety. So, addressing these issues through ongoing innovation is essential for the future of electric vehicle, and ensuring they remain efficient, safe, and environmentally responsible. This is basically what we conclude in our study. And after that, of course, there are some future recommendations in this domain, which are future research should aim to strengthen the data accuracy, improve battery temperature control, and make state estimation in BMS for electric vehicles more accurate. And of course, these improvements are key to overcoming current challenges and ensuring that electric vehicles remain reliable and sustainable. Furthermore, working on better recycling methods and reducing production costs will help address environmental concerns. And of course, we can get rid of sustainability and disposal issues as well, and support the wider use of electric vehicles around the world. In the end, I would like to thanks to my all collaborators. Especially, I'm thankful to Dr. Rozan Bodwille uh, for being external supervisor of this project, and also other co-authors who contributed in this in conducting these studies. And these are the references that we cited in the end. Thank you so much for listening. If anyone has any question, please welcome.